In this lesson, we'll create our first Rust project, which we'll call Hello World. A Rust project will be a regular directory on your computer that's going to hold the source code, the developer code that makes up the project. Now, when we installed Rust a few lessons ago, the installation also included a tool called Cargo. Cargo is a command line tool that helps manage Rust projects. For example, it has commands to create projects, to compile the executable program from the source code, to format the code, and more. Cargo is the recommended way to create a new Rust project because it gives us a nice starter template and enforces consistency across projects. Later on, you'll download the course materials, which will consist of many Cargo projects, but for now, we can create one from scratch. So in your directory of choice, it can be anywhere, we're going to execute cargo space new to create a new Rust project. Afterwards, after another space, we're going to add our project name, which will be hello_world. Cargo project names can vary slightly in how they are written, but one common formatting option is called snake case formatting, where every text character is written in lowercase and every two words are separated with an underscore. So what we see here on the screen is an example of snake case formatting. The words are in lowercase and I'm separating every two words with an underscore. You also cannot have spaces in the project name. It must be one consecutive piece of text. All right. So I'm going to execute this command by pressing enter, and Cargo is going to create some starter files and folders. You can feel free to delete this project, by the way, at the end of this section. Rust projects are also called packages as well as crates. You'll soon learn that in programming, there's often a lot of similar terms for the same idea. So project, package, crate, you're going to hear those terms used often interchangeably. You'll notice that the output says created binary application package. There's actually two types of Rust packages or Rust crates, and they are binary crates and library crates. A binary crate is a standalone Rust application whose purpose is to be run by itself in isolation. In comparison, a library crate is one that exists to be used in other projects. It's not standalone, it's meant to be incorporated into another Rust project. So to give you a real-world analogy, think of a binary crate like a car. It's a fully functional piece of machinery that you're able to use automatically. In comparison, a library crate is more like a tire or an engine. Its value lies in being applied in other places. An engine could go into a car or a bus or a lawnmower, but its purpose is to be used elsewhere, right? That's the purpose of a library crate, to be incorporated into some other binary crate. So by default, the cargo new command creates a binary crate, its own independent application. So this Hello World project is intended to be a standalone program, and that is exactly what we're going to want for most of the course. So with that, I'm going to use my cd command to navigate into my Hello World directory, and then I'll execute code, followed by a space and a dot. This is going to open VS Code in the current directory. The code command means open VS Code from terminal, and the dot means open the current folder. So execute that command, and I'm going to bring over VS Code from my other screen. So let's talk about the files and folders that were created by Cargo. The source directory right here is where our Rust code will live. Source refers to the source code of the program, the actual developer code. And the word source, S-O-U-R-C-E, is frequently abbreviated as src just for brevity. So right now, the src directory contains a single main.rs file. All Rust files end in the extension .rs. And here we can see some sample Rust code. We're going to come back to this in the next lesson, but we're going to be writing all of our actual developer code in these .rs files within the source directory. The target directory is where the compiler will place the executable that it builds from our source code. The executable is the resulting program that comes from this code. It's the program that we're actually going to run on the computer as the final product. This is just for the benefit of developers. Target is going to have the final executable program. Next up, we have a git ignore file. This is strictly for the benefit of the Git version control system. It tells Git which files and folders to ignore. In other words, to avoid adding to your source control. We're not going to be using Git extensively, so we don't have to worry too much about this git ignore file. This cargo toml file includes information and metadata about the project. In case you're curious, toml stands for Tom's Obvious Markup Language, and it's a plain text file where we define keys and values, which you can think of as definitions for now. For example, this toml file configures a project name of Hello World and an arbitrary version number of 0.1.0. So the cargo toml file just stores information about the Rust project that we can customize and update over time. The Rust Analyzer VS Code extension that we installed is going to use the presence of a cargo toml file to understand that the project is a Rust project. So it also helps establish the connection with that VS Code extension. Finally, we have this cargo.lock file. This is automatically generated by Cargo whenever we compile our source code, whenever we build the final executable. You should always include the cargo.lock file in your Git source control, but you should never actually modify it yourself. It's going to be updated automatically by Cargo. It exists primarily to keep track of your project dependencies. For example, when your project incorporates some library crates, some other code built by other developers, the cargo lock file will keep track of those crates as well as their versions. So that's a quick introduction to the initial contents that Cargo New will create for us. You don't have to memorize all these files and folders just yet. Remember, the most important takeaway is that the developer code is going to live within the source directory, and that's where we're going to write our first piece of Rust code in the very next lesson. Let's begin this lesson by opening the main.rs file in the source directory and deleting all of its code. We're going to rewrite this code from scratch in this lesson so we can discuss what it's doing in greater detail. So as I mentioned, our Rust code lives within files with a .rs extension that is short for Rust. So this file, main.rs, is an example. Rust code within these files consists of functions. A function is a procedure. It's a collection of steps or sequential instructions for the program to execute. I often like to compare a function with a cooking recipe in the real world. A cooking recipe is a sequence of instructions, right? Step 1, mix the egg and the flour. Step 2, add the sugar, etc. It's the same idea here, where a function defines a recipe that Rust can run in order. A Rust program will typically consist of many functions. Functions exist for the purpose of organization. Ideally, each function, each recipe, has its own small responsibility. For example, if we were writing a Rust program that read in a file from our hard drive, parsed its contents, and wrote something to a new file, we could split that program into 3 functions, one to read, one to parse, and one to write. There's no right answer as far as how many functions your program needs. It all depends on how you, the developer, want to organize your code and break up the tasks that the program will be doing. Every Rust function begins with the function keyword, which is abbreviated fn. So fn tells Rust that we are beginning a function declaration, the definition of a recipe. Afterwards, after fn, we add a space and then declare the function's name. Every function will have a distinct name, which allows us to distinguish between them. Now, every Rust program must have a function called main in all lowercase. So I'm going to write out that function name, right? It's important to note that Rust cares about case sensitivity. So this function name must be written in all lowercase. A main function with a capital M is a different idea. The main function is the entry point to the program. Rust will automatically execute the main function first. It's going to look in our code for the main function definition and run that automatically. The technical word for executing a function is called calling the function or invoking the function. So we can say something like, when the program runs, Rust will invoke the main function. After the function name, we declare a pair of parentheses, both opening and closing. That's going to be Shift plus 9, then Shift plus 0 on your keyboard. Now you'll notice as soon as I add my opening parentheses, VS Code and Rust Analyzer will automatically provide the closing parentheses. This is expected behavior and one example of how the text editor makes it easier to write code. You can think of it like a nice autocomplete feature where it saves us a key press. All right? The parentheses are where we declare what are called parameters. A parameter is an input for a function. An input is something we want to pass into the function for it to use. If you think back to the cooking analogy, we can think of parameters as the ingredients to the recipe. The recipe consists of some sequential steps to follow, but it may require some ingredients or inputs to work with for these steps to run against, and that's what the parameters represent. Now, a function does not need to have parameters. For example, our main function in this scenario will not have any parameters, but the parentheses is where we declare those expected inputs, and they are required even if our function will accept no inputs. Afterwards, we're going to declare a pair of curly braces, and I'm going to add a space after the closing parentheses. By curly braces, I mean the characters to the right of the P on your keyboard, and I have to hold Shift to access them. They look like this, right? This is the opening curly brace, and this is the closing curly brace, right? So this creates what is called a block. You can think of a block as the section between an opening and closing curly braces. It's a section of code. We can add a few line breaks here. It will make no difference. And the area between the opening and closing curly brace is the code that is going to belong to the main function. This is the code that's going to run when the main function is invoked. We call this section between the opening and curly braces a block. So the function's body, which means its content, will be written within these curly braces, within this block, and that's how Rust understands that it belongs to the main function. This is where we put the steps belonging to the main recipe. As far as formatting, the common convention you'll see is what we have here. We're often going to place the opening curly brace on the same line as the function name. Then we're going to write our code across several lines, and then we're going to close the function or close the block, provide the closing brace on its own separate line. Inside the body of the main function, we're going to write one line of code that's going to output text to the screen. It's a long-held tradition in programming. You can even say a rite of passage that the first piece of text that we output is hello world. So we're going to honor that tradition and have our first Rust program simply output the text hello world. Now, for all of this content inside our main function, the Rust convention is to indent your line of code 4 spaces. So 1, 2, 3, 4. All of our code will be indented 4 spaces in, and that simply exists for the benefit of readability. Now, on my VS Code, you can see down below here, I have spaces :4, and that indicates that VS Code sees a tab as equivalent to being 4 spaces. So here, I can delete my spaces and press the tab key to accomplish the same effect, the equivalent of 4 spaces. All right. So in order to output text, we'll use something called a macro. A macro is somewhat comparable to a function. It's technically different behind the scenes, but for now, we don't have to worry about the differences. Think of a macro just like a function. It's a recipe, it's a procedure that we can utilize. It's somebody else's code that's already been written that's going to be responsible for something else. In this case, the technical responsibility of outputting text to the screen. So our macro is called println, P-R-I-N-T-L-N. Line is abbreviated to LN, and we also have an exclamation mark at the end. You can think of that as a regular character that is part of the macro's name. It's kind of a distinguishing visual feature that reminds us it's a macro. But from Rust's perspective, there is no difference between alphabetic characters versus the exclamation mark. It's just a character that is part of the macro's name. All right. So all macros are going to have the exclamation mark in their name. We are referencing this macro, but we need to provide a pair of parentheses to actually run it. You can think of this as invoking a function. It's very similar. This is where we actually take a recipe, in this case println, and we cook it. In other words, we tell it, follow the instructions in the println macro and actually execute it, output this content to the screen. So inside here, we need to provide a piece of text. And the way we declare a piece of text is with a pair of opening and closing double quotes. As soon as I add my first one, Rust Analyzer will automatically autocomplete the closing one. Rust will understand this piece of text by the presence of the double quotes, the start and the end. Otherwise, it would get confused and think that the characters we write in here are some part of Rust syntax. So we need this to create a piece of text. In programming, the technical term for a piece of text is called a string. So when we use these double quotes, we create a string. In here, I'm going to write my content, hello world. All right. You can see that a string can consist of alphabetic characters, but it can also consist of other characters like spaces or digits or symbols. Like, for example, I can pretend I'm really excited and add an exclamation point at the end. That's a valid character to include within a string. Then Rust sees the closing double quote and knows that the piece of text has concluded, that it's been terminated, and everything moving forward is a regular part of the Rust syntax. Okay, there's one more thing we need to do, and that is we need to terminate the line. We basically need to tell Rust that this line is done, that we've expressed a full thought, a full instruction, a full command. And the way we do that in Rust is by adding a semicolon to the end of a line. Semicolons terminate the line statement. You can think of it like the period at the end of a sentence, right? So with that, we are ready. The next thing we need to do is to save the file. So on a Mac, I can use the shortcut Command S, and on a Windows machine, I can use Control S. Notice that this white little circle in our tab for the file is present. This circle indicates that the file is unsaved. If you have not saved it, then these changes will not have registered because it won't be saved to the file's content on your hard drive. So before you run any program, make sure that you save and the circle goes away because now these changes are in the file. Okay? So finally, the last remaining step is to actually run the program, and luckily the Rust Analyzer extension offers this nice run button above. Now this button is actually going to do a couple things. The first is it's going to compile the program. It's going to parse our source code and compile it or translate it to the actual executable program on our hard drive. It's a totally separate file, right? That file can run even if your computer does not have Rust installed. It's the final output, the final program. So the run button here will create that executable, and then it's going to automatically run it. So compilation and execution, it's technically a two-step process, but the run button here will do it all with one click. So I'm going to press run. We're going to see a panel pop up. Note that your panel may pop up on a different part of the screen, like the right side or the left side. Don't worry about it. Those differences don't matter. Don't worry about this content right here. Here is the actual core part of our program. Here is our actual executable program outputting the text hello world, which is exactly what we defined using our print line macro. So this is a valid working Rust program that is reflective of the code that we wrote, right? So if I want to update this and celebrate and say, hello world, I am a Rust developer, the process is the same. I'm going to update my code within the main function, save my file, press the run button, and now we see that this Rust program and its resulting executable output a different piece of text to the screen, which includes the additional content in my string. All right. So quite a lot of concepts explored in this section, but this is the heart of it. This is a valid working Rust program. Every Rust program will include a main function. A function is a procedure of steps in order. In this case, our procedure only has a single step or instruction, and that instruction tells Rust to output content to the screen using the print line macro. The word print simply means output to something. We'll talk about where the line comes in a future lesson, but this means output some content to the screen. The content is specified within the parentheses, and we have to tell Rust that it's a piece of text, a string with a pair of double quotes. And finally, we need to terminate the line with a semicolon, right? I know there's a lot of concepts to explore here. It's kind of hard to introduce Rust or any program like this from the start because there's a lot of these ideas that are coming at you all at once. But rest assured, every Rust program we're going to write will involve a main function and involve this syntax, so you'll have plenty of chances to practice it throughout the course. All right, that's all there is to cover in this lesson, so I will see you in the next one.